This video will take you through the final page of the Module 3 practice test, where we continue to practice with some trigonometry questions. In these two questions, we're going to solve the triangles, which means we calculate all the values for any unknown sides and angles, and we'll put our answers in the table provided. For each question, we'll include a sketch. When we're done our calculations, we'll round our sides to one decimal place and angles to the nearest degree. In part A, we're given a right triangle, knowing that angle A is 13 degrees, angle C is 90 degrees, and side A is 12 degrees. For a sketch, I can make a right angle triangle. I know 90 is my angle C. I can label the other angles A and B. I'm told angle A is 13 degrees. I can label my sides, remembering that across from angle A is side A, labeled with a lowercase. Across from angle B is side B. And across from angle C is side C. In the question, I'm also told that side A is 12. I'm going to put the values I know in the table as well, because it can help me look and see where to start the question. A is 13 degrees, C is 90 degrees, and side A is 12. Solving the triangle means finding all the unknown values, so in this case, angle B, and side C. You can choose where to start. I'm going to start here. I know two angles, so calculating the third is easy. Since I know that all the angles in a triangle add up to 180 degrees, I can just take the measures for the other two angles away. So subtract 90 degrees and subtract 13 degrees. So I can do 180 minus 90 minus 13, and angle B is 77 degrees. Now I also need to calculate side B and side C. When we have a right triangle, we can use either the trig ratios, coming from SOHCAHTOA, or we can use the Pythagorean Theorem, c squared equals a squared plus b squared, depending on what information we know about the triangle. In this case, I can't use the Pythagorean Theorem right now, because to use the Pythagorean Theorem, I need to know two sides. So I'm going to use a trig ratio, which means I need to label my triangle, and I'm going to label it based on the angle I was given. That way, if I made a little mistake with angle B, that's not carried forward. So I'm going to label my triangle from angle A. So across from angle A is my opposite side. Across from the 90-degree angle is always my hypotenuse, and beside angle A then is my adjacent side. And I'll pick what side to solve for first. I'll solve for side B. I could find C first if I like, doesn't matter. If I'm finding B, I look at what I know. I know an angle and I know the opposite side. If I'm looking for side B, that's my adjacent side. So I'm going to use the tan function. From your formula sheet, tan of an angle is the opposite side over the adjacent side. From the question, putting in what I know, tan of 13 degrees. My opposite side is 12. My adjacent side is side B. We can rearrange here to solve for B. We can think of this as cross multiplying. I'm dividing by B on the right side of the equation, so I multiply on the left. So B times the tan of 13 degrees equals 12. To get B by itself, I divide each side by the tan of 13 degrees. As you've done more of these questions, you may be able to go right to this rearrangement. B equals 12 over tan of 13 degrees. So you may go right from this step to here, and then you can punch it in on your calculator. Make sure your calculator is in degrees, and then 12 divided by tan 13 equals 51.977. Rounded to one decimal place as our question says. Side B is 52.0. Last thing to do is solve for side C. I could use the Pythagorean Theorem now that I know two sides. If I'm doing that, I need to use the unrounded value of B. So I find it easier to go back to my given values and use a trig ratio again. Again, I know angle A and the opposite side. If I want to find side C, that's my hypotenuse. The trig ratio that has hypotenuse and opposite side in it is the sine function. From your formula sheet, sine of an angle is opposite over hypotenuse. So sine of 13 degrees is opposite side is 12 over the hypotenuse is c. You can rearrange as we did in the last question, or if you're used to the pattern and how it works, you can go right to here. C equals sine, or 12 over sine of 13 degrees. Basically, these have switched places. And then on your calculator, 12 divided by sine 13 is 53.3449, or to one decimal place, 53.3. You can check and make sure all your answers make sense. Across from your largest angle, the 90 degree is your longest side, 53.3, and across from your smallest angle is your smallest side, and all the angles add up to 180 degrees. We'll practice with one more right triangle. So we'll solve this right triangle being told that side A is 30, side B is 45, and angle C is 90 degrees. Again, we're asked to do a sketch. So I can label my angles and my sides. I know side A is 30 and side B is 45. Angle C is 90 degrees, my right angle. I can decide where to start. In this case, I only know one angle, so I can't quickly calculate the other two. I do know two sides, so I can quickly calculate the third using the Pythagorean Theorem. So I'm going to find side C. Because I know two sides, I can use the Pythagorean Theorem. C squared equals a squared plus b squared. So c squared equals 30 squared plus 45 squared. If you want to do this all in one step, you can, or you can do this calculation first. 30 squared plus 45 squared is 2,925. Just remember that that's c squared. To find c, I need to square root each side. So on your calculator, you can just square root that answer, and we get 54.0832, or to one decimal place, 54.1. And now I need to work to find my other two angles. I'll need to use the trig ratios for this, so SOHCAHTOA. And I'll look for angle A first, so I'll label my triangle first based on angle A. Across from angle A is my opposite side. Across from my 90 degree is always my hypotenuse. And beside angle A is my adjacent. I need to know two sides in order to calculate the unknown angle. I know the opposite and adjacent side, so that comes from the tan function. So if I want to find angle A, the tan of angle A is the opposite side over the adjacent. So tan of angle A is my opposite side is 30 over 45. To get A by itself, I use the inverse tan function. So angle A on my calculator, I use the inverse tan, so second function of tan, and then, and then I bracket 30 divided by 45, close the bracket, 33.6900. To the nearest degree is 34 degrees. To find angle B now, I could look at subtracting the angles I know from 180 degrees, but I like to calculate based on the values I was given, so sides A and B. That way, if I've made a mistake calculating angle A, I can catch it. So I'm going to find angle B using trig ratios, which means I want to relabel my triangle from angle B. From angle B, side B is my opposite side, and side A is my adjacent side. Side C remains my hypotenuse. So I can look at using the tan of angle B is the opposite side over the adjacent. With those sides relabeled from angle B, the opposite side is 45 over 30. To get B by itself, I move the tan over with its inverse function. And then I can go to my calculator. So second function of tan, bracket 45 divided by 30 is 56.3099, or about 56 degrees. Now I can check and make sure all my angles add up to 180 degrees, which they do. My largest angle, 90 degrees, is across from my longest side. My smallest angle across from my smallest side. That wraps up the Module 3 practice test. Make sure to get in touch if you have any questions.